in this video, we want to calculate the cross product between vector A and C. Okay, and the two vectors have been given in this diagram. Okay, so you can see that the vector A is along the negative y-axis. It has magnitude 8.0 meters. And the vector C has magnitude 0.0 meters lying in the xy plane. Okay, it is making an angle of 25 degrees with the negative x-axis. So as you can see, the angle between the negative x-axis and the vector C is 25 degrees. Okay, so you want to find the cross product between A and C. So there are two ways of doing this. Okay, it's either we use the definition for the cross product between two vectors. So we know that if we have two vectors A and C, okay, and we know the angle between them and their magnitude, then the cross product will be given by, so A cross C. The cross product between A and C is given by the magnitude of the vector A times the magnitude of the vector C, then sine of the angle between A and C. So sine of phi. So phi here is the angle between A and C. And in this diagram, as you can see, the angle between A and C should be 90 minus 25, which should be 65 degrees. So we can write this. So the magnitude of A is 8.0 meters, as you can see over here. So we have, so in the bracket, 8.0 meters times the magnitude of C is also 12.0 meters. So we have 12.0 meters. Then sine of the angle between A and C, remember it is 90 minus 25. Okay, so it is this angle here. Okay, so 90 minus 25, that will be 65 degrees. Okay, then you see this, the cross product between A and C gives us a vector. Now the vector has this magnitude, so its direction was n hat. So n hat here is the unit vector that gives us the direction for the new vector. Okay, so when you when you cross two vectors, we get a new vector. And we know that vectors have magnitude and direction. Okay, unlike the scalar product where you multiply two vectors and you get a scalar. So you don't worry about the direction. But for the cross product, when you cross two vectors, you get a new vector which has magnitude and direction. So the direction in this case is n hat. And the magnitude side is this expression. So this gives us the magnitude of A cross C. And the direction is n hat. Now, if you multiply this out, you realize that 8 times 12 is 96. We have into bracket 96.0. Then m times m, that gives us m squared. Okay, so m for meters. Okay, we have 96.0 meters squared. Then we have sine of 65. So sine 65 degrees and hat. Now, if you compare this solution to the possible answers, we realize that all the angles in the possible answers are in terms of 25 degrees. So what that tells us is that we should find a way to rewrite sine 65 in terms of any of the angles here. So we should get 25, okay, as the possible answer, or the possible answers at end. So we know from high school that sine of theta, okay, so we know that sine of theta is equal to cos into bracket, so we have cosine of 90 minus theta. Okay, we know this. So sine of theta is equal to cos into bracket 90 minus theta. So what that tells us is that sine of 65 degrees. Okay, so we go to cosine of 90 minus 65. So this will equal to cosine of 25 degrees. Okay, so it means that we can rewrite our answer as, so A cross C now is equal to 96.0 m squared. Then we have cosine of 25 degrees. So this gives us the magnitude of A cross C. So now all we have to do is to worry about the direction. Okay. Now, if you are using this method, then you have to use the right hand rule to determine the direction for this vector A cross C, which most people find it difficult. So let's use another method that will give us the direction very simple. Okay. So in that case, what we have to do is we have to resolve the vectors A and C into their component form and use a different method. So let's use a different method. Okay. So now let's see. So let's resolve the vectors into their component form. So we can write the vector A to be equal to negative 8.0 z hat. So this is a vector A. It is along the negative y-axis. So it is just equal to negative 8.0 j hat. It has no x component and it has no z component. On the other hand, the vector C, okay, the vector C can be written as cxi plus cyz. Okay, so C has x and y component because it is lying in the xy plane. Okay, it is lying in the xy plane. So this is our x-axis and this is our y-axis. Our y-axis is the vertical. Okay, y-axis. Okay, so because of this, the vector C is having two components, the x component and the y component. So let's see how we do this. So we can find the x component of C, and this will be equal to C cosine of, let's say, cosine of theta. Okay, now this theta here, in this problem, we are reading the angle theta from the positive x-axis, okay, counterclockwise, all the way to where the vector C is located. Okay, so theta will be this angle, this obtuse angle. So the angle went from the positive x-axis all the way to where the vector C is located. And that angle should be 180 plus 25, which is 205. So we have that the x component of C should be equal to 12 cosine of 205. Okay, and this will give us, so this would be equal to negative 10.875. So this is the x component of C. Now we can find the y component of C in a similar manner. So that is C sine of theta, and that is equal to, so we have 12 sine 205, which should be equal to, so that is negative 5.0714. Okay, so this is the y component of the vector C. So now we can calculate A cross C. So we can say that A cross C, the cross product between A and C, is equal to the determinant of the 3x3 matrix between A and C. So let's see that. So we can form the matrix, a 3x3 matrix for A and C this way. So the first entries are the unit vectors I, J, K, right? Then for the vector A, we know that the S component is 0. It has a Y component, which is -8, and it has no Z component. For the vector C, it has an X component, which is -10, 8, 7, 5, 7. And it has a Y component, which is -5.0714. And the Z component is 0. Okay. So now, so this is how we do this. So if we take I, we delete down and across. So we have I into, so we delete down and across. So we have -8, 0, -5.0714, and 0. -8, 0. Okay, so -8, 0, -5.0714. Okay, so this is I. Then we have minus Z. So the conversion is plus, minus, plus. So we have minus Z. We delete down and across. So this will give us 0, 0. Then we have -10.875 and 0. Okay. So let me write this there. Okay. Then we have plus K hat into, so K we delete down and across. So we are going to have 0, -8. Then we have -10 and 8757. Then we have 0. So then write the -8 here. This is all we have. Okay, so let's simplify this. So this will be equal to, so we multiply the leading diagonal and we subtract the other diagonal, the multiplication of the other diagonal from it. You're going to have -8 into 0 minus 0 into -5.071. Then minus J hat into, so we have 0 times 0 minus 0 into -10.8757. Then finally we have, plus K hat into, so we have 0 times 0 minus, into bracket, -8 multiplying -10.8757. So you realize that, okay, over here I omitted an I, so there's an I here. So over here 8 times 0 is 0, and 0 times -5.0714 is also 0. So this whole thing goes to 0. Okay, so the I component goes to 0. Now let's come to the J side. We have 0 times 0 minus 0 times this. So this also goes to 0. Okay, so the only term that survives is the K term that survives. So we are going to have, this is equal to, so we have 0 times 0, which is 0, minus -8 times -10.8757. So this should be equal to -87.0056 K hat. Okay, so now we can see that A cross C is equal to -87.0056 k, which is exactly what we get when we do this. So when we multiply 96.0 meter squared cos 25, we get negative 87, we get 87.0056. Okay, so the negative sign over here, notice that the magnitude of the vector can never be negative. Okay, the magnitude of the vector is always positive, but the direction is negative ki. Okay, so if you multiply 96 by cosine of 25, we get 87.0056, but then the direction for the vector is negative k hat, as we can see over here. So it means that we can come back here and write that the vector A cross C is equal to 96.0 meters squared cosine of 25 degrees. Then the direction is negative k hat. So this will give us negative 96.0 meters squared cosine of 25 degrees. So this is the correct answer. Notice that we use this method to get the direction. Okay, so we found the direction using this method, and over here we found that the direction is negative k hat. Okay, but the magnitude over here is the same as the magnitude we had over here, which is the same as 96 cosine of 25. If you multiply 96 cosine of 25, we get 87.0025. Sorry, 0056. So this is how we solve this problem.